Hey guys, welcome to the video for parallel/perpendicular lines. We are in Unit 4. Our essential question is how can I tell if two linear equations are parallel, perpendicular, or neither? So we've spent a couple days just talking about parallel lines and then also talking about perpendicular lines separately, and now we're going to kind of put it all together. And so we are going to introduce some new things here, and sometimes when things are really easy, they can also be easy to forget. So just make sure that we don't forget how to do just the normal stuff with parallel and perpendicular lines. Being able to write a parallel line or a perpendicular line just based off the equation, right? So if I gave you a point, and I asked you to create a perpendicular line, then I would use the equation that I was given, find the slope, make it the perpendicular slope, and then use point slope form with my new point. All right, so, and then some of this video, you'll see some things that you've seen before. Okay, so what makes lines parallel? Well, the way that I can tell that two lines are parallel, not without graphing them, is by looking at their equation. And when I look at that equation, I want to see that they have the same slopes. Anytime that two lines have the same slopes, they're never going to intersect each other. So they're never going to touch, so they're parallel. So an example would be if I had an equation and the slope was 5, then in the other equation, I would also want a slope of 5. So 5 and 5 would be examples of the same slope. Well, a non-example would be like saying 5 and -5. Those aren't the same slope, or 5 and 6, right? Those are two non-examples. Okay. What makes lines perpendicular? Well, to make lines perpendicular, you need opposite, reciprocal slopes. And just to remind you, opposite means I either go from positive to negative or negative to positive, so my sign changes. It's an opposite sign. Reciprocal means I flip the fraction. So if I had, say for example, 1/3, then it would change to 3/1, and vice versa. So let's do some examples. One example would be if I had 2/3 and, well, the opposite of a positive 2/3 would be negative, and then I would flip the fraction, so -3/2. A non-example would be saying 2/3 and 3/2. Now these are reciprocals, but they're not opposites, so that would not count as an example. And same thing with 2/3 and -2/3. Those are still not opposite reciprocals. It's opposite, but not reciprocal. It has to be both. Okay, so for the first 6 problems, we're going to determine if the lines are parallel, perpendicular, or neither. Remember, parallel lines have the same slope, perpendicular lines have opposite reciprocal, and then if it's neither, then it's just neither. So if they don't have the same slope and they don't have opposite reciprocal slopes, then it's just neither. They're going to cross each other, but there's nothing special about them. Okay, so starting in number 1, y equals 3x minus 7 and y equals 2x plus 5. Now I first want to make sure, can I tell the slope from the form that it is in? Well, they're both in slope-intercept form, y equals mx plus b. That's the form that I want it to be in so that I can see the slope. Well, in the first equation, I'm going to do each equation in different colors. So the first equation, my slope is 3. In the second equation, my slope is 2. Are these exactly the same slopes? No, so they're not parallel. Are they opposite reciprocal slopes? No. So what does that mean? It's neither. It's not parallel or perpendicular. Okay? I'm not asking you to create a parallel slope or to create a perpendicular slope. I'm asking you to determine if it's parallel, perpendicular, or neither. If I'm asking you to determine it, I'm asking you that using what you see and what you have, tell me yes or no, basically. So the common mistake is that I ask you what the slope is, and then you say you make it perpendicular, like, oh, -1/3. Okay. We want to make sure that we're looking at what we have. I'm telling you to determine, right? If I ask you what color shoes you have, then you're going to tell me the color of your shoes. You're not going to change shoes and be like, oh, now it's this color, okay? So again, you're determining. You're not asked to create a perpendicular or parallel slope. Okay. First equation, this is in y equals mx plus b, so I know what the slope is because y is by itself. The slope here is -5. Do I know the slope of the second equation? No, because y is not by itself. Now, I do want to tell you that there is an imaginary 1 next to this x. So if I want to get y by itself, the first step is I have to subtract 1x on both sides. So I have negative 5y equals 3 minus x. Okay, I'm going to keep going, right? So I'm going to divide everything by negative 5. Negative 5 divided by negative 5 cancels. I have y equals negative 3 over 5. Now, there is a negative 1 right in front of this x. So negative 1 divided by negative 5 is positive 1/5 x. So what is my slope for this equation? Positive 1/5. This is my slope. This is my other slope. Are these parallel, perpendicular, or neither? Well, parallel, they'd have to be the same, so they're definitely not parallel. Are they perpendicular? Yes, because negative 5, if I want the opposite reciprocal, it would be positive, and then if I flip 5, it's going to be 1 over 5. So positive 1 over 5. So these are perpendicular. Okay, moving on to number 3. Now, number 3 looks a little bit strange. It's just numbers. Now, they're only numbers, and sometimes when I say, hey, if it says x-axis or y-axis, graph, because visualizing it is great. So with something where it's just x in a number and y in a number, I would like you to graph those lines, because it turns out that they're either going to be horizontal lines or vertical lines. With the last two examples, I would not want you to graph these, because they are diagonal lines, and so you would need all of your coordinates and all of that to be able to graph these lines, so I would not recommend it, because in each equation you have a y and an x in both equations. You see that? There's a y and an x in each. But in these, there's only one variable. So if there's only one variable, I would recommend graphing. So let's go ahead and graph. I'm going to go ahead and draw tick marks. And I'm going to copy this so we can save it for later. Oops. All right. So I'm going to graph the first one in green. So x equals 3. Well, if it's x equals, what axis is it going to be on? On the x-axis. What am I going to plot on the x-axis? Positive 3. On the x-axis, I'm going to plot a positive 3. Now the question is it a vertical line or a horizontal line? Well, do you see how my tick marks here go up and down? Do you see how this black tick mark goes like this? You're going to follow the tick marks. You're going to go straight up and down with it. So this is going to be a vertical line. Well, what's the slope of vertical lines? Well, remember back in Unit 3, it makes a U for undefined. The equation is x equals 3, but the slope is undefined. Okay. Now the equation y equals 2. It says y equals, so that means it's going to cross the y-axis at positive 2. Same thing here. We see that the tick mark goes side to side. So we're going to create a line that goes side to side, or also known as horizontal. This is a slope of 0. If we remember from back in Unit 3, it makes a z, right, for 0. Or you can also just say m equals 0, right? Now, 0 and undefined are actually opposite reciprocals. They make a 90-degree angle right here. They do. They make a 90-degree angle. They're opposite reciprocal slopes, so these are perpendicular. And I'll show you why in a second. Okay? Well, if I have a slope of 0, that means that I have 0 over some number, right? Well, an undefined slope means that I did a number divided by 0. If I try to do number divided by 0 in my calculator gives me error. That means I have an undefined slope. But here I'm always going to get 0. So do you see how they're opposite reciprocals of each other? It doesn't matter what the number is. So it could be a negative number here and a positive number here, or a negative number here and a positive. So they're opposite reciprocals of each other. It's just hard to think about. But again, if it's a horizontal line and a vertical line, they're opposites of each other, so they're perpendicular. So we're going to be dealing with a lot of that on the next page. Okay, number 4, y equals x plus 3 and y equals negative x plus 2. Now on this one, I'm going to warn you to be careful because it is one that we get stuck on sometimes. So in the first equation, I want to make sure I can identify the slope. It is in y equals mx plus b form, so I can go ahead and identify slope. My slope here is positive 1, not 1x. There's a 1 here, not 1x, okay? And in the second equation, I can also identify the slope. It is negative 1. Now, you're looking at it and you're like, I don't know. Are they parallel? No, they're not exactly the same, right? Are they perpendicular? Well, let's find out. Let's look at this slope first. Positive 1. Positive 1 means if I wanted the opposite reciprocal, well, what's 1 as a fraction? 1 over 1, right? If I want the opposite reciprocal, that would be negative 1 over 1, which is what? Negative 1. Isn't that what I have? So, 1 and negative 1 are opposite reciprocals of each other, which means that it's going to be perpendicular. This one's pretty tricky, and I'll tell you why it's tricky. And it's because we confuse it with another thing. Sometimes when we see slope of 3 and a slope of negative 3, we're like, well, they're not parallel because they're not the same, but they're not perpendicular because they're opposites but not opposite reciprocal. Remember, reciprocal means you flip your fraction. If I wanted reciprocal, I would want 3 and negative 1/3, or negative 3 and positive 1/3. But the reason why these are not perpendicular is because these are 3 over 1, and this is negative 3 over 1. If I were to flip either of them, there's going to be a 1 in the numerator. But when I have a 1, well, the numerator and the denominator are exactly the same. So I would just have 1 over 1, negative 1 over 1. That's why these are perpendicular, where these are not. Okay, moving on to 5. This one looks a little bit strange too, because again, you're just having a letter and a number. But anytime you see that, your go-to is to always graph. It's always good to visualize. You want to graph when you only have one variable involved in your equation, because it'll either be a horizontal line or a vertical line. So I copied my graph from earlier. Okay, y equals 5. So I'm going to graph this on my y-axis at positive 5. So I'm going to have to do an extra tick mark for positive 5 here. Positive 5, and it's going to follow the tick mark, so it's going to go left to right, horizontal. My slope here is 0. Okay? My slope is 0. My equation is y equals 5. The slope is 0. Okay, well, in the second one, 3y equals 6. Well, oops, I got rid of the 0 on accident. 3y equals 6. I need to get y by itself because I can't graph it yet. So let's go ahead and get y by itself. Divide 3 on both sides. Y equals 2. Well, that means it's on my y-axis. So go ahead and plot y-axis on your positive 2 and follow the tick mark. Are these lines ever going to intersect each other? No, because both of their slopes are 0. Do they have the same slope? Yes, which means they are parallel to each other. All right, last one to determine. X equals negative 1 and x equals 2. Again, anytime you see a variable adjusting number, the best bet is to graph. All right, so I'll graph the first one in green. X equals negative 1. So it's on my x-axis at negative 1, so we're going to plot a point there. Now you see how the tick mark here goes up and down, so you're going to follow it. It's a vertical line. Well, what's the slope of a vertical line? Undefined, because it makes a U, right? Okay, and the next thing I'm going to have is, let's move this, whoops. Move this here. Okay, and then I have x equals 2. So on my x-axis, I'm going to put a point at positive 2. And then I'm going to draw a vertical line through that because I'm going to follow the tick mark. Well, the slope here is also undefined. The equation is x equals 2, but the slope is undefined. And for the green one, the equation was x equals negative 1, but the slope was undefined. Are my slopes exactly the same? Yes, they're both undefined. If I have the same slope, then they're parallel. The key thing with the ones where you have to graph, if the letters are the same, they're going to be parallel to each other. So in here, the y's were the same, they're parallel. X's were the same, they're parallel. But in here, they're opposite. If I have opposite letters, then they're going to be perpendicular to each other. So again, you're just identifying the slope and determining if it's parallel or perpendicular. You're not asked to create a new slope or anything like that. Okay, on the next page, we're going to talk about vertical lines and horizontal lines a little bit more. So when I'm talking about vertical lines, those are lines that go straight up and down. So they look something like this. And what would the slope be for this? Well, the slope is always undefined. And if I look back, every time I had a vertical line, the equation was always x equals because it goes through my x-axis. So notice here, both of these equations are vertical lines and they both go through the x-axis. Same thing with the green one here. X equals 3, it's a vertical line. So it is always written as x is equal to a number. And again, if I see just a variable and a number, I want to graph. But if I see more than one variable, don't graph. Okay. The next type we see is horizontal lines. And horizontal lines go side to side, left to right. And the way you remember is that it's like a horizon. A horizon like a sun. When you see a sun on the horizon. So just remember that as horizon. Horizontal. Okay. The slope for here is always 0. You can also write the number as well. You don't have to spell out the whole word. So remember back in unit 3, undefined is a U, Z for 0. And since those horizontal lines always go through the y-axis, they're written as y equals. So y equals a number. So that's going to be really important for these next few problems. All right, so number 1, we want to write an equation parallel to x equals 2 and goes through -1, 3. So since I see the word parallel, that means that I want to create a line that does not intersect. So that means non-intersecting lines. So I'm going to highlight parallel. The first thing I'm going to do is I'm going to graph. So why do I want to graph? Well, I notice that I have x equals 2. So anytime I say, hey, make something parallel to the x-axis, parallel to the y-axis, parallel to x equals 2, anything that's just a letter and a number or an axis, we want to graph because it's way easier for us to visualize. Whoops. Trying to shrink it. Okay. So we're going to graph x equals 2. Well, x equals 2 is going to be on the x-axis at +2, and we want to follow that tick mark. It's x equals, so it's going to be a vertical line. And then I want to plot the point -1, 3. -1, 3 is going to be at -1, +3, so right here. Okay. Now I want to make a parallel line to x equals 2. So do I want it to cross the red line or be never touching it? Never touching, because we want it parallel. Because I want it parallel, it's never going to intersect. So it's also going to be just parallel to that red line. So what's the equation of this orange line? We want to write an equation, right? We don't want to just stop there and be like, hey, I'm done. We want to write an equation. So what is our equation? It goes through the x-axis at what number? -1. Okay. Trying to think of what to do with my dot here. Okay, moving on. And that's it. Super easy, but again, it's easy to forget too because it's so simple. Write an equation parallel to y equals -1 and goes through 4, 2. All right, well, let's go ahead and plot our graph here. I want to graph because I see y equals -1. If I just have a letter and a number, I want to graph. But if I have more than one letter, don't graph. Okay, so we're going to graph y equals -1 on our graph here. So it's going to be on the y-axis at -1, and we're going to follow those tick marks. We're going to go side to side, left to right. Okay? And then we want to create a new equation that goes through the point 4, 2. So let's plot the point 4, 2. That's going to be right here. Now we want to create a line that's parallel. So do we want to go left to right or up and down? We want to go left to right. We don't want it to cross the red line because we want it to be parallel. So if we want it to be parallel, it's going to look something like this. It's going to be another horizontal line. Well, what's the equation of this line? That's what we really care about because we want to write an equation. So it goes through the y-axis at +2. Right here at +2. Our orange line goes through the y-axis at +2. All right, next one. Write an equation perpendicular to, so we have a different word here, perpendicular. We're not doing parallel anymore, we're doing perpendicular. Perpendicular means I want my lines to cross each other. So y equals 3 is the graph that we want to make it perpendicular to, or the line we want to make it perpendicular to, and we want it to go through 2, -2. Well, this is my first equation, so we're going to go through the y-axis at +3, follow the tick mark, so y equals means it's going to be a horizontal line, and then we want to plot the point 2, -2. Okay, we want to make a line that's perpendicular to it. Perpendicular means I want to cross it. So do I want to go left to right or up and down? We want to go up and down. Go through that point. Go through that orange point. But, again, you want to write an equation. That's the whole point of this. I'm not asking you to graph. The graph is just to help us. That's not the answer to our problem here. So it goes through the x-axis. Our purple line goes through the x-axis at positive 2. All right, moving on. Last problem. Write an equation perpendicular to x equals -4 and goes through 3, -1. Again, since I see the thing where it says just a letter and a number, I'm going to graph. So we're going to graph this. X equals -4. I'm on my x-axis at -4. I'm going to follow my tick marks. It's going to be a vertical line. Now, keyword here was perpendicular, so I don't want parallel. I want to plot 3, -1 on my graph. We want it to be perpendicular, which means I want it to go through the red line. I want it to cross at 90 degrees. Okay, so my purple line goes through which axis? It goes through the y-axis at -1. All right, so that is it for the new part of the lesson today. So we did a lot of horizontal and vertical lines. But again, you still want to be able to see slopes of equations that are not horizontal and vertical. So again, these would not be horizontal and vertical lines because you have a y and an x in each equation. So it's going to be a linear equation, just not vertical or horizontal. If you have something that has just a letter and just a number, like these two on the right here, then you would graph to help you see. But if you have any questions, just please feel free to come in for tutoring.